What's going on, everybody? Got another video here for you. This is area of a surface of revolution. It's not very difficult to do. It's pretty interesting. So let's get started. So it says f is positive and has a continuous derivative. We define the surface area of the surface obtained by rotating the surface y equals f of x, where x is between a and b, about the x-axis, as s is equal to the integral a to b 2 pi f of x times the square root of 1 plus f prime of x squared dx. And we've got just the different notation, the Leibniz notation. You can see it's the same. Instead of f of x, they use y, and they use dy dx instead of f prime x. It's the same thing. And if the curve is described as x equals g of y, where x is written as a function of y, then y is between c and d. Then the formula for the surface area becomes s equals the integral c to d 2 pi y times the square root of 1 plus dx dy squared dy. All right. And both of these formulas up here that we looked at, we can summarize them as the surface area is 2 pi y times ds, or 2 pi x ds, the integral, where ds is the square root of 1 plus dy dx squared dx, or ds is 1 plus dx dy squared dy. We can use either one, either ds. Okay, we can use either one of these, and I think that'll make a little more sense when we start working the problems. These problems that they can be set up different ways, and we'll actually set up one of the problems. We'll set it up two different ways. Depending on how you set it up, sometimes the integral could be difficult to work, and you set it up depending on which way you set it up. So if you set it up, it's hard to integrate. We'll set it up the other way, and it might be easier. So basically, what we have here is here's your formulas, and you've got your graph, your figure, and it's rotated. This one's rotated about the x-axis. So you can see that the y, this y here, that's your radius from the axis up to the graph. And then the 2 pi y, that's just the circumference of it. Okay? Because remember, 2 pi, that's the circumference, or, well, think of it this way. Pi times the diameter is the circumference. So we've got pi times the radius times 2. We're taking the radius, multiplying it by 2, multiplying by pi, and that gives us the circumference. And then the same thing if we're rotating about the y-axis, 2 pi x ds, where x is your radius. You can see here x is the radius, and the 2 pi x is your circumference. Okay, so let's look at some problems. And it says the curve y equals the square root of 4 minus x squared, where x is between -1 and 1, is an arc of the circle x squared plus y squared equals 4. Find the area of the surface obtained by rotating this arc about the y-axis. All right, so if we draw us a little sketch of this. Now remember, this 4 minus x squared, that's a semicircle, right? Okay, so, it's a semicircle. Just think, x squared plus y squared equals 4, that's a circle. The square root of 4 minus x squared, that's the top half of the circle. So what we have here is like this little piece right here. Because, see, the semicircle goes all the way down here like this. And this would be your -2 and 2. But see, we're only going from -1 to 1. So we stop when x is -1 and 1. So that's going to be like here, the -1 and the 1. And we're rotating it about the x-axis. And, I guess if you want to, you can draw this, and you would have, something like this. if you were looking at it. Something like that. And honestly, you don't really need to draw all that. I mean, you can. It might help you. It might not. I don't know. But see, we're rotating about the x-axis. So here's our radius right here. Okay? And you can see this radius is y, right? So let's look at it this way. We're going to use the formula. The surface area is going to be a to b 2 pi, and what are we going to use? Y times the square root of 1 plus, what are we going to do? Dy dx dx. See, we're going to use, where is it? See, we're going to use this formula right here. All right, so, and this is squared. All right, so we've got to find the derivative of y. So we've got y equals the square root of 4 minus x squared. So the derivative, now I don't know if you've watched any of my other videos, but I do have a video just on this. But there's a shortcut for finding the derivative of a square root. And it's like this. It's 2 times whatever the square root is. Okay, that always goes in the denominator. And then what goes in the numerator? Well, the derivative of what's underneath the square root. So that's minus 2x. So we get negative x over square root of 4 minus x squared. So there's your dy dx. And so now we plug everything in. So s is equal to the integral negative 1 to 1. 2 pi. Now remember, we're going to integrate with respect to x. So that's 2 pi times y. Well, what is y? Y is the square root of 4 minus x squared. And then that's going to be times the square root of 1 plus negative x over the square root of 4 minus x squared dx. All right, so we got everything plugged in. So this is going to be negative 1 to 1, 2 pi square root 4 minus x squared times the square root of 1 plus, and that's going to be x squared over 4 minus x squared dx. Okay, once we square that. And so now we got negative 1 to 1, 2 pi square root 4 minus x squared times the square root. Now here I'm going to get a common denominator. So let's just come over here, and we've got 1 plus x squared over 4 minus x squared. So if we get a common denominator, 4 minus x squared, 4 minus x squared, we're adding. This is going to be 4 minus x squared. That's going to be x squared. So we're left with 4 over 4 minus x squared. All right. All right, so that's going to be 4 over, let's see, 4 minus x squared dx. All right, so this is negative 1 to 1, 2 pi square root 4 minus x squared times, now look at this, that's the square root of 4 is 2, and then the square root of that is just square root of 4 minus x squared dx. So I just took the square root of the numerator, square root of the denominator, and you can see that those cancel, and I'm left with negative 1 to 1, and that's going to be 4 pi dx. See that? Not too bad, is it? Ended up working out pretty good. And so this is going to be 4 pi x from negative 1 to 1. So that's going to be 4 pi times 1 minus negative 1, which that's going to give us 8 pi. And that would be your surface area. All right. So, some of these can get nasty, when you're integrating them, but, it's not that bad. All right, so let's look at the next one. We've got the portion of the curve x equals 2/3 y to the 3/2 between y equals 0 and y equals 3 is rotated about the x-axis. Find the area of the resulting surface. All right, so let's just go ahead and sketch a quick graph of this. So this graph is going to look something like that. Okay, and we are rotating about the x-axis. Okay. All right. So let's see. Well, let's look at this. We've got x equals 2/3 y to the 3/2. That's our function. So, well, think about it. We're going to take we could take the derivative of x with respect to y. Isn't this x equals something in terms of y? And remember, there's your radius. This is the axis you're rotating it about. So from there up to the curve, that's your radius. And that value's y, right? All right. So we've got our surface area is going to be the integral. Okay, so let's look at this. Well, first let's do dx dy. That's going to be y to the 1/2, right? 3/2 comes down, subtract 1. All right, so we've got, let's see, 2 pi y, right? That's the radius, times the square root of 1 plus y to the 1/2 squared dy. See, we got everything in terms of y, so we're going to integrate with respect to y. And so our bounds are 0 to 3. 0 to 3. And there's your integral. Okay? All right. Now, you could do this. You could set this up the other way too. And we might do that after we work this. I don't know. We'll see. But there's your setup right there. Okay? So here, this is going to be 0 to 3. And I tell you what, I didn't do it in the last problem. But how about we just go ahead and do it in this one? Pull that 2 pi out. We probably, we could have done it up here. Why didn't I? I don't know. I just didn't. But, if you want to, go ahead and pull the 2 pi out. Sometimes it'll make it easier to integrate. So that's going to be y square root 1 plus y dy. All right, so now do we remember how to integrate this thing? We're going to let u equal 1 plus y. du is dy. And so this is going to be 2 pi integral. All right, so let's look at this. So the 1 plus y, that's going to get replaced with u. So, and then the dy is going to be replaced with du. But I still have this y here. I've got to get this y in terms of u. So what's y? Well, doesn't this right here mean y is equal to u minus 1? So I've got u minus 1 times, and that's going to be u to the 1/2 du. And then we need to change our bounds also. So I've got u is equal to, so I'm going to take the 0 and the 3, plug it into here to get u. So that's 1 plus 0 is 1, and u equals 1 plus 3, which is 4. So we're going from 1 to 4. And so this is 2 pi times the integral 1 to 4, u to the 3/2 minus u to the 1/2. So just distribute the u to the 1/2 du. And so that's 2 pi times, that's going to be u to the 5/2, 2/5, minus u to the 3/2, 2/3, and that's 1 to 4. And so that's 2 pi times, that's going to be 2/5 times 4 to the 5/2 minus 2/3 times 4 to the 3/2 minus, and then that's going to be 2/5, 1 to the 5/2 minus 2/3 times 2/3 1 to the 3/2. Okay, and then this, you can just take this and you can plug it into your calculator. You got 2 pi times, let's see, 4 to the 5/2. The square root of 4 is 2. 2 to the 5th is 32, so that's 64 over 5. Minus, that's going to be 2 cubed is 8 minus 16 over 3. Minus 2/5 plus 2/3, and that all ends up being, let's see, 232 over 15 pi. All right, so you'll have a calculator. You can punch all that into your calculator, unless you're in my class. My students don't get to use calculators. All right, so there's that one. Now, as far as setting this up the other way, I don't know if it would be any better. You would basically, if you solve this for y, you would have that. It would probably be worse if we did it that way. You would have 2/3 x to the 2/3. No, you would have 3/2. 3/2 equals y. So you would have to do that, and then just think, you would have to take the derivative of this. Okay, you would have to take the derivative of that, and the derivative of that would go here, and then this would go in the place of y, and then that would be dx. And of course, then you would also have to plug the 0 into here, which would be 0. Then you would have to plug the 3 into here, and that would be your upper bound. So you can see it would be more complicated to do that. Okay. So I hope you understood what I just showed you there if we did it the other way. But if not, this next problem here, we're going to set it up both ways, and you'll be able to see it. All right, so it says the arc of the parabola y equals x squared from x equal 1 to x equal 2 is rotated about the y-axis. Find the area of the resulting surface. All right, so let's sketch that graph. And so this is a parabola. It starts here, right? It goes like this, but we're going from 1 to 2. You see that? So, whoop. No. Come on. All right. So we don't need that whole side there. So you can see we're just going to have like that. Okay. And if you drew it over here, you would have something that looks like this. That would be the figure that you would have. Okay. But I'm just going to draw. Let's see. We're just going to draw. Let me undo all. Whoop. We're just going to draw that part. And then keep in mind, there's your radius. You see that? We're revolving about the y-axis. So there's our radius from the axis out to the curve. Okay. All right. All right. So let's just set this up first. We've got y equals x squared. Let's set it up, and we're going to integrate in terms of x. So our radius is x, right? There's your radius. So s is equal to the integral, and then I need dy dx, which is 2x. So I've got 2 pi x, right? 2 pi x times 1 plus 2x squared dx. So there it is. All right. Now, what's my bounds? Well, it gives them to me right there, 1 to 2. 1 to 2. And so now I have s is equal, and let's go ahead and pull the 2 pi out. I'm going 1 to 2 of x square root of 1 plus 4x squared dx. All right, so now to integrate this thing, we've got u substitution. So we're going to let u equal 1 plus 4x squared. Du is 8x dx. All right, so now you can see here, we're going to replace the 1 plus 4x squared with u, and then the 8x dx. See, we've got x dx. We're missing the 8 here. So we multiply by 8, so that means we got to go out there and divide by 8. And so we get pi over 4 times the integral of u to the 1/2 du. Okay. All right, and we've got to change our bounds. So we've got u equals, and so we're going to take each one of the bounds, the 1 and the 2, plug it into here. 1 plus 4 times 1 squared is 5, and u equals 1 plus 4 times 2 squared equals 17. So that's 5 to 17. And so that's going to be pi over 4 times 17 to the 1/2 minus 5 to the 1/2. And that is equal to, let's see. Oh, I'm sorry. I'm such an idiot. I'm sitting there concentrating on something else. I didn't even integrate the stupid thing, did I? All right. I'm not even going to cut that out of the video. I'm going to let you see where my mind just wandered off. So I've got pi over 4 times u to the 3/2 times 2/3 from 5 to 17. All right. And so that is going to give us pi over 6 times 17 to the 3/2 minus 5 to the 3/2. And as far as that goes, I don't have a decimal answer for it, but we could actually just write this. Now keep in mind that, well, let's just look at the 5. The 17 will be the same thing. 5 to the 3/2, that's the square root of 5 cubed, which is the square root of 5 squared times 5, which is 5 square root of 5. So we can write that as 17 square root of 17 minus 5 square root of 5. And there's your answer. All right. So that wasn't too bad. All right. So that's how we can set it up, and you know that's probably the easiest way to do it. I don't really know because I haven't set it up the other way, but let's set it up the other way and see. So we're doing y equals x squared. So this is setup number 2. Y equals x squared. And we're going from x equal 1 to x equal 2. All right, so let's look at this. So here's our graph again. And remember, there's our radius. That's x. Well, we can take this and write this as x equals the square root of y. And so dx dy is equal to 1 over 2 square root of y. That's the derivative of square root of y. Okay? So we're going to get s is equal to the integral. That's going to be 2 pi. All right. So the derivative that we're plugging in is in terms of y. So that's telling us that our function that we're integrating is all going to be in terms of y. So our radius is x, right? Okay, our radius is x times the square root of 1 plus, and that's going to be 1 over 2 square root of y squared dy. Okay, so look at this. All right, so notice this right here, this is an x. That is our radius. But we're integrating with respect to y. So what is x? X is the square root of y. So that's square root of y. And we are going from, now remember it says x is from 1 to 2. Okay, so y is equal to 1 squared, which is 1, and y is equal to 2 squared, which is 4. See, I've got to take these x values, plug them into here to get my y values, because my bounds have to be y values. So I'm going from 1 to 4. And so this is going to give me, and I'm going to pull the 2 pi out, 2 pi, and we're going to go from 1 to 4 of square root of y times the square root of 1 plus, and that's going to be 1 over 4y dy. All right, so let's see what we've got here. Well, this is going to be 2 pi from 1 to 4. Now, look at this. I can actually multiply this. So you remember there's a property in algebra that says the square root of a times the square root of b is equal to the square root of ab. So if I've got 2 square roots, I can just multiply what's underneath. So that's going to be the square root of y times, and I'll write this step out, 1 over 1 4y, 1 plus 1 over 4y dy. So that's going to be 2 pi from 1 to 4. And that's going to be the square root of y plus 1/4 dy after I distribute that y there. And so you can see here, this isn't very difficult to integrate here. This is just another u substitution. So u equals y plus 1/4. So du is dy. So that's going to be 2 pi integral u to the 1/2 du, and then we're going to have to change our bounds. So I got to plug the 1 and the 4 into here. So I've got u is equal to 1 plus 1/4, which is 5/4. And then I get u is equal to 1 plus 4 over 4. No, I'm sorry. Is 4 plus 1/4. So that's going to be what was that, 17 over 4? All right, 17 over 4. And so that's going to be 2 pi times u to the 3/2 times 2/3 from 5 over 4 to 17 over 4. I hope I didn't make an arithmetic mistake anywhere, but if I did, oh well. You get the idea of what's going on here. So that's going to be 4 pi over 3. And that's going to be 17 over 4 to the 3/2 minus 5 over 4 to the 3/2. And then whatever that comes out to be, I'm not gonna attempt to put that in the calculator. So I think that's good enough. This example here. If you're in my class, you can leave it like that. If your teacher lets you use calculators, just throw that in your calculator and do it like that. All right, so let's look at this one. It says set up an integral for the area of the surface generated by rotating the curve y equals e to the x from 0 to 1 about the x-axis. All right, so e to the x, and that's 0 to 1, so that's going to look something like that. We're rotating about the x-axis. So here we have a radius of y. It's probably going to be easier to just put everything in terms of x. So I've got y equals e to the x, and I've got dy dx is equal to e to the x. All right. So I've got s is equal to, we're going to go from 0 to 1, 2 pi, and that's going to be y. My radius is y, but remember I'm going to be in terms of x. So y is e to the x times the square root of 1 plus e to the x squared dx. So that's going to go 0 to 1, 2 pi e to the x square root of 1 plus e to the 2x dx. And there it is set up. And then for this one, you would want to probably just pop that into a program. The problem actually just tells us to actually the directions. I didn't write all of the directions, but it says exactly what I have written here, and then it says then evaluate the integral numerically correct to 3 decimal places. So it's something like you would maybe want to use you could use Simpson's rule, trapezoidal rule, something like that. But when you do that, actually they give the answer from a calculator. It's 22.943. Okay. So the other option that they don't tell us to set it up this way, but let's set it up. We've got y equals e to the x. Let's set it up integrating with respect to y and see what that integral looks like. So that means we're going to get this. Well, look at this. Here we are. There's our graph. There's our radius right there, right? So we're going to want to be in terms of y. See this radius here. I don't know what I'm hitting when it does that. All right, so this radius here, that's y, right? So we need to write this as x equals the natural log of y, right? If we change this to logarithmic form, okay? So that means we're going to have s is equal to, well, we need to know what our bounds are. So we've got 2 pi, and so we're going from x equals 0 to x equal 1. So that means y equals e to the 0, which is 1, and y equals e to the 1, which is e. So we're going from 1 to e, and our radius is y times the square root. Now here we've got dx dy. Dx dy, which is 1 over y. That's the square root. And so that's going to be 1 plus 1 over y squared dy. So s is 1 to e 2 pi y square root of 1 plus 1 over y squared dy. And that one, I don't know. That one might be kind of, that one could be rough to integrate also. But I wanted to set it up to just show you the other option. Okay. So basically what it is, you know, you're going to decide, are you going to set it up in terms of x, or you're going to set it up in terms of y? Which one are you going to do? Okay. And then once you decide which one you're going to do, the main thing is that radius. Okay. So if you're going to set it up in terms of x, or if you're going to set it up in terms of y, your derivative, you've got to get, if it's in terms of y, you've got to get x equals something in terms of y, so you can take that derivative. And then the radius, well, it's y here, so it's just going to be the y. But over here, we said, okay, we want to set it up in terms of x. So we got y in terms of x, so there's your derivative. And then your radius, now remember, your radius is y. See, that's your radius, y. But you're going to be in terms of x, integrating with respect to x. So what is y? Well, y is e to the x. It's really not that difficult. I hope you get the concept and understand what I'm trying to tell you. Because if you do that, they're easy to set up. All right. All right, so I hope that video helped. I hope you learned something. You feel smarter now. But check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.